Okay, problem 3. Previously we said that this was either going to be a ratio test or an integral test problem. So let's try the integral, or let's try the ratio test first. The ratio test, if we look at the a sub n plus 1 term, that's going to be n plus 1 squared over e to the n plus 1 cubed. All right, and I can rewrite that as n plus 1 squared, or actually I'm going to rewrite it as n squared plus 2n plus 1. And on the bottom, e to the n plus 1 cubed, well, n plus 1 cubed is going to be n cubed plus 3n squared plus 3n plus 1. Now, it's not terribly important that we write all that out, but when you do e raised to this, you get e raised to all that. So you get e to the n cubed plus 3n squared plus 3n plus 1. So when you do the ratio test, take the limit as n goes to infinity. The n plus 1 term is going to be n squared plus 2n plus 1. This is going to be e to the 3n, or I'm sorry, e to the n cubed plus 3n squared plus 3n plus 1. And what about over here? Let's see, we've got to multiply by the reciprocal of the original. So that's going to be n squared on bottom and e to the n cubed on top. And let's see, can we do anything with this? I think we can. Let's rearrange this stuff. N goes to infinity. You got n squared plus 2n plus 1 over n squared. And then the other term is going to be e to the n cubed. I should be careful. That's not a term. It's multiplied by this, so these things are factors. So let's see, there seems to be a cat fight going on behind me here. If it gets out of hand, I'll have to intervene. All right, e to the n cubed on top. And downstairs, I've got e to the n cubed. I'm going to write this out times e to the 3n squared plus 3n plus 1. Because I can, those are exponent rules, we can do that. This is going to go to 1 over here. This and this cancel. And so we're left with something where we've got nothing but 1 left on top, and we've got this left on bottom. So this limit is going to go to basically 1 over infinity, or 0. So that's less than 1, so therefore this is going to converge. That's one way to do this problem. We could also do it with the integral test. If we did it with integral test, we'd integrate, let's see, the original function up here, that'd be x squared over, or let's don't write it as a fraction, let's just write it as x squared e to the minus x cubed dx. And you go from 1 to infinity. So let u equal minus x cubed, du is minus 3x squared dx. So let's see, x squared dx is going to be minus 1/3 du. So I can rewrite this. This becomes e to the u. This and this together become minus 1/3 du. And my endpoints, let's see, this becomes negative 1. This up here becomes negative infinity. We're taking infinity, cubing it, which still is infinity, and then making it negative. So we get this. We get minus 1/3 e to the u from -1 to -infinity. When you plug those in, or formally we should write it as a limit, but let's see what happens. 1/3 e to the -infinity. You raise e to the -infinity. Basically, you're following the function of e to the x. That gives you 0. So plugging in the -infinity gives you 0 minus -1/3 times e to the -1. It gives you a number. It's not that important what it is. It's 1/3e. But the important thing is it's a finite number, so it converges. All right. So we did that one two different ways, using the integral test or the ratio test. Both of them give us that it converges. If you do these, and I mean, you'll never get two tests that tell you two opposite things. You might get one test that fails to tell you anything, and then another one that tells you what happens. But if you ever did two different tests and got converged with one and diverged with another, there's a mistake somewhere in there. So I think I'm going to stop this video here because that was a lot of work on one problem. But we'll pick up with number 4, 5, and 6 in the next video.